Okay, so I'll just go back one slide. So the really quickly, the summary is that experimentation is hard. We're not going to cover everything today. So we'll really narrow down our scope today, and um, let's get into well. So there's real world experimentation, which is Galileo's story of how he discovered gravity in that domain. So how does it look like here at Mercari? Here's an actual example of an experiment that we did with the Mercari app. Um, in this experiment, we have a screen that shows the customer items we think they currently have in their possession. And on this screen, I don't know if this is several years old, so you may not have the screen anymore. But when this experiment happened, the original experience showed prices for each individual item as well as the total of all those items together. And the experiment was very simple. All we did was we hid prices. In the first case, we just hid the top price, which is the total. And then in the second treatment group, we hid all of the prices. What do you think would happen in this case? Do you think there would be an effect? Anyone have an idea? Do you think there would be an effect? No effect? Just a guess. You don't have to. So if you think there would be an effect, raise your hand. No one thinks there would be any effect. So we'll go back into this later, but keep in mind what would have happened, what the result would have been for this experiment. If you imagine if we did find an effect here, so if the customers were sensitive to whether they saw the prices or not, then you can imagine that this would inform us of how we should design our app experience. For example, let's say that the treatment groups actually perform worse than the control is not actually what happened. But for example's sake, if the treatment groups perform worse than the control in terms of listing rates, then this would inform us that actually customers may actually want to see prices, but more than that, it informs us something about their behavior. So specifically that they're sensitive to whether prices are visible or not. So that's experimentation at Mercari. We start with an hypothesis, ideally, and then we run a randomized controlled trial or experiment, and then we analyze the data after collecting it. Quite simple. Now, quiz. Why do we run experiments? So we got to take a step back. Why this is why experiments are important to us, and since we're in the Chat GPT era or the LLM era, I've given you the answer of Chat GPT. Chat GPT selected answer number 2. So who thinks that Chat GPT is correct? You can raise your hand if you think Chat GPT is correct. A lot of thinking faces. I think ChatGPT is correct because I wrote the question. And the reason why this is correct is because this is, if we learn from our experiments, it will inform us about behaviors we can expect from our users. And therefore, it makes all of the other options on this, all the other answers possible, except possibly answer number 3. So recapping to reinforce this, we run experiments to learn something, and then we apply our learnings to how to make our app or service better. Now, you may be wondering, can we do without experiments? Is it enough to just collect data on and observe our users' behaviors and infer from correlations in the data? And so here's an actual correlation of 2 very interesting metrics. So this is one in line. The red line is per cheese how much cheese each person consumes, and then the black line is how many people died because they got tangled in their bed sheets by year. And you can see there's an obvious correlation. So one conclusion you could draw from this chart is that, well, obviously, if you get tangled in your bed, if you die because you got tangled in your bed, you're probably eating a lot of cheese, right? Or vice versa. But we all know that this is unrealistic. Like this is there's it's very unreasonable to make this assumption. Something more realistic for us, though, is something like this. Now, this is, I'll tell you that this is fake data, but this does, we can find this in the data occasionally, which is that on one axis, we have the number of purchases our customers make over time, and then, I mean, just how many purchases they make versus how often the app crashes for them, how many issues they run into the app. And and so this correlation could actually be real. Any ideas why this could actually be true? Like what could cause this correlation to occur? Like we're just like thinking right now, but correct. So if you purchase a lot, you might be using the app more often compared to someone who purchases like very few items, right? So your time on the app is much longer, and so you're more likely to encounter a crash. So, so this is the danger with looking at correlations. So correlations do not establish causality. That's why we need experiments. For those of you familiar with experiments, you may know something about the counterfactual. Um, in short, the counterfactual is just uh, maybe it's better to explain it as an example. So, like, let's say you have a headache, and it's a really bad headache, and you really want it to you want to do something to get rid of your headache. So you have two choices. You can just wait it out and hope that your headache goes away naturally, or you can take some medicine that will relieve your headache. Um, and so, in both cases, eventually your headache will disappear. But how do you know that if you took the medicine, that it was because of the medicine that your headache went away? This is the counterfactual, is that you don't actually know that because you can't go back in time and untake the medicine. So, um, so another more correct way to say it is that we have a control in a treatment case, and the same subject cannot experience both. So we take a random sample, divide them up uh, equally, and then we assume that the null hypothesis is true, which is nothing will happen if we apply a treatment. And then we look at, we measure both groups equally, and if there is an effect statistically, then we can expect the null hypothesis to be invalid. So you don't need to know that in detail, but that's just in here for reference. Okay, let's now switch into how we would implement an experiment here. We'll go over some technical details now. Um, so there is something called an experiment design. PMs should be utilizing this. I don't know to what degree, but I assume everyone in the room is an engineer, so I'm not going to go into this. Now, there's something called an AA test, and unfortunately, we don't make this easy, but ideally, if you can do an AA test before you actually run your trial, then this will eliminate a class of problems that may occur during the actual trial run. Specifically, an AA test could identify whether or not you have a sample ratio mismatch. These are very notorious, and these do happen in the company. It happened several times now. And so the unfortunately the AA test has to be run before the actual trial. So why does the AA test have to run before the trial? Does anyone know? Let me rephrase the question. In what condition would the AA test have to occur before the trial? I'll give you the answer. So if let's say, well, I'll give you another hint. Let's say your team decides to use all of the population of all Mercari users. They want to run this experiment, and let's say um, it's a new Mercoin initiative that we're going to run some kind of. We're going to trial like a sort of like how credit cards work. So if you sign up and you start using Mercoin, we'll give you like 1% on top of your what you spent. So this is the trial, and your PM is like, we need to use all the users. Can we run an A test after the trial has completed? Is it possible? So it's not possible because you've used all of the users. So you have randomly distributed it across all the users, and unless you know who exactly went into the control group and did not experience it, they've already been affected by the treatment. Um, so they already are aware of that you're running they're not aware you're running the experiment, but they're aware of the effects of the treatment. Let's say so they'll be used to having this benefit. Um, and so if you were to run an A test after that, you're just testing for like whether you get the same ratio, but you're not going to be able to actually run your experiment again. The other thing that does happen is there is often a bias that's detected after the trial. I'll give you an actual example that happened recently. There was a team that had a special user that integrated with a partner service in cross border, and uh, it affected the search results for for the Mercari Marketplace app, where after a certain rollout, once this user got included into the randomization, um, it caused an insane amount of traffic to be delivered to one treatment compared to the other treatments. Fortunately, this was very obvious to the team because it was essentially crashing the service that was serving that treatment. It was a search related service, and they noticed it immediately. So they could we could figure out that there was this special user that was affecting the treatment. But the more nuanced case is when it happens and you don't quite detect it, but gradually you see over several days that there's a bias creeping in because one group is performing slightly better, or there's just more users, like 1 to 2% going more into one other group. Um, and it's very annoying because you've already set the rollout, and so we can't take that back and just say, well, let's find all the control users. Like that's not how our system works. Those are some nice techniques. Now, more technically focused topics. Well, these are really peculiar to our system. This is a link to the dashboard. I'm not going to go over that. Um, Now, on a technical basis, here's how users get assigned in randomized experiments. Um, so any client will start the app, and in this case, client includes other backend services, um, and then the client has to make a request to our platform API, and they'll get a response if successful, and and in that response will be a set of parameter assignments, and then we'll get into why that is. And then the client will apply those treatments such that the user will now have a different experience. Um, and then once the user actually experiences the treatment, note that this is not once the client requests the experiment assignment. Once the actual user sees the treatment, let's say, at this point, the client should emit an event log. This is very important. We'll get into that later. So I mentioned that there's a difference between a parameter assignment and a treatment, and this kind of shows you why. So this is an example of a raw response for an example experiment, and in this case we have two parameters that are being applied to this particular user. In this case, there's a lister tutorial parameter and then a video path, and both have like values. And along with that, there's an experiment ID and a treatment ID. And so the obvious question is, why don't we just base the source code off of treatment IDs? Like, couldn't we just send the treatment ID and then know which experience to enable? And this is possible, but this would create an issue where now our source code is tied, our client source code is tied to treatment IDs and experiment IDs rather than configurable parameters. So, for example, let's say we wanted to run a second experiment using the same parameters. So instead of this tutorial video, we wanted to change it to a different video in a follow-up experiment. If we tied it to treatment IDs, we would not be able to do this without redeploying the code and updating it. If we did use parameters, then we don't have to do this. We can just feed the client a new configuration and treat it as a new experiment. How are populations randomized? It's kind of complicated, but here's an actual example. The short answer is that we can have an infinite number of layers split across a tree of domains. So each domain is basically a partition of traffic. In this example, the top level domain gets all the traffic, followed by two subdomains, each has 40% and then 20%. And then within each domain, we can have layers, an infinite number of layers. And then within each layer, you can have many experiments. And then the user is assigned for every layer they end up in. Let's say that our potential user ends up in this improvements domain. So this user will be assigned to both layers within the subdomain. So improvement A layer and improvement B layer. And there happens to be two experiments or one experiment for each layer. And so this user should experience both experiments if there were 100% experiments. And likewise with the other domains and whatnot. So this lets us create subgroups on which we want to experiment. We also have a function that lets us hold out users so we can run an experiment in another domain and then explicitly exclude them from all parameter settings for those layer experiments. And then later use them either as a comparison to how other experiments went or run an experiment within the holdout domain. Randomization unit targets. So keep in mind that you can just always refer to this. I'm just giving you a tour of all of the details. So we have only two randomization units available, user ID and UUID. UUID is kind of a nebulous thing. It does apply to users that are not logged into the app, which is why it's used. But it has an issue, which is that the UUID can be regenerated in certain unexpected conditions. So one day we'll fix it. But if possible, you should try to use a user ID. And if your team ends up using a UUID, just know that it has issues. And also, we also have targeting. So your configuration, your new app configuration for your experiment or feature flag may only be within a certain app release. And so or worse, you may have released an earlier version and notice that there's an issue with it, and so you don't actually want to enable it for those clients. And you can use targeting to limit which clients receive this treatment. In fact, you must now apply targeting. Otherwise, you would include every service and every request in the experiment. One very key feature you'll probably end up using is something we call a user override. This allows you to take any user in either environment, development or production, and force them to receive a particular set of parameter values. The most obvious way to use this is to apply an existing treatment configuration for either a future file or experiment and see if the client or the user actually experiences it. Um, Another way to use this is to force users out of randomization. So you might recall that we had this special user that was special for specifically for cross-border that caused all these issues. Um, this particular user probably should not be in any experiment ever. And so we could use this feature, this override feature, to purposely exclude them from all randomization forever. There's one gotcha here, which is that user overrides do not send treatment ID or an experiment ID. And this usually means that you will not see event logs for these particular users. Lucky for you guys, there are client libraries for pretty much most use cases in Mercari, so web, iOS, Android, and also Go services. You can look at that more in detail on your own time. However, there are still some details that we need to get correct. One of those is defaults. So let's say you implement an experiment, and for some reason, experiment platform is down, the API is down. What should your code do? So like we can give a more concrete example. Let's say you're part of the Mercari home screen team. So when the app loads, it's going to fetch some results to show on the home screen, and once it's ready, um, it's just going to go. But your team's running an experiment on the home screen right now that dramatically changes how it looks. Um, and so if well, what do you do when you get like a 404 or a 500 HP error from our API for experiments? Like, do you not load the home screen? Do you crash the app? Like, what are some ideas? It's on the screen. So, so you could have a fallback default, which is that this default always works. So even if you don't know which treatment to apply, you default to this treatment that still shows something the user can work with. Not recently, but in the past, this has led to incidents, just so you know. So um, always think about the failure mode for when the app cannot apply a treatment. Then we have some caching behavior in some of the clients. You can look at this in more detail, but the clients make their requests at specific points in time and they cache the values. So there are cases where the client will not actually update until the user restarts the app, for example. Okay, event logging. Another very important detail is we while we can emit event logs automatically, it does not mean that it's correct. And one key decision you may have to make is the appropriate time when you should emit an event log for when a user experiences a treatment. Sounds very simple on the face of it, but when you're in the code, it's easy to get wrong. And also consider that the logging events, so emitting event logs has a cost. So you can't just log everything, let's say. So here's an actual example of that we'll go through on uh, how important the timing is. So let's say we have this screen, which so there's a search screen that shows the results of the user's query, and we also show like random things in there. But for this particular case, a team wants to interleave search results when too many sold items are in the search results. So you can imagine that if you do a search and all that comes up on your search screen is just sold items, but you actually want to buy something. This is kind of a bad experience, right? And so what this team wanted to do was to uh, figure out if interleaving some other kind of results that might be somewhat related would help the experience a bit. So rather than seeing relevant items that are all sold. You would see relevant items that are all sold plus maybe slightly related, but different items that are still available to buy. But the way this was implemented was that this interleaving the results with these other unsold items was going to require a secondary query to our backend. And the question is, based off of this implementation, what is the right place to log? When do we log the event for this experiment? And so here's some. This is not the actual code, but this is just some pseudocode that describes what I just that does what I just described. And so here we have the actual search followed by a check for whether or not the treatment is enabled. And if it is enabled, then we perform the secondary query, and then we interleave the results, and then finally we show the results, um, regardless of whichever branch we took. And the question is very simple: when do we event log? So the first option is when we get the parameter assignment from the API. Second option is when we fetch related items. So when we call the secondary API as part of the experiment. The third option is when the client code actually puts the two results together. And the final option is when the client actually renders and shows the user the results. And you can pick your answer, and then I will show you the right answer since we're running out of time. And the right answer is when we show the results. So it's quite obvious, but again, like if you just implement this feature and you rely on the automatic logging mechanisms, um, you may actually be logging when the APIs are getting called, not when the user is actually being shown the results. So when does this fail? So if we rely on the automatic logging when the APIs are called, you can if this interleaver and if the second API fails, for example, the user may never actually see the results. Maybe our client code is buggy. Maybe there's a condition for when it receives the response that causes this new API to fail. And then we don't handle this properly in the client. In this case, when we enable this experiment, the treatment group will not actually be experience a treatment as you would think. Okay, so this is just so there are event logs. That system is called Laplace, and you can go look at more details there. But there's also something called an experiment API access log or assignment log. You can use this to see what our platform actually assigns the user, but it does not mean that the clients actually apply the treatments. Then I'll give you a few minutes before the next session. Thank you.